Background. All right, guys, we're just jumping in. This should be a review for you of special right triangles. We've got 30, 60, 90. Those are the formulas you use to solve for the missing sides. H stands for hypotenuse. LL is long leg. SL is short leg. Just L is leg. Okay. Henry?
Did it say anything about that?
Nope. These are your special right triangles. You can label it as that if you would like. You're going to use this on your warm-up, guys, so I just want to make sure you've got it jotted down, your formulas. Is this familiar to you somewhere in your brain from geometry? Yeah, you still needed to learn things. Well, okay, then this will be a little... This is a 3. I'll read it. Hard to wait. All right, guys, solve 1, 2, and 3. Welcome, Jackson. Solving for x and y using those formulas you wrote down from the first slide. Yes, please. Ready, guys? Check in with someone around you. See how you did. You don't need Pythagorean theorem. You can use the 45, 45, 90. You could get there with Pythagorean theorem, but
This is shorter. This is longer across. That's a lot.
Right?
all right, guys, let's go through these. In number 1, I gave you the short leg. That's the easiest kind of problem, because to get the long leg, which is x, you just take the short leg times root 3. And to get the hypotenuse, what do we do? Yeah, short leg times 2. So that should have been your answers for number 1. Yep. No, you're supposed to already know this. So, yeah, that should be in your brain. If you didn't pay attention in geometry, you're gonna have a little extra that you need to do. That was your choice. All right, guys, second one, 45, 45, 90. Remember, hypotenuse is equal to root 2 times a leg. So just plug in what you know. The hypotenuse is 10. Root 2 times either x or y, they're the same. How do I solve?
You divide by root 2.
Yep, so I have 10 over root 2 equals x. How do I rationalize? So I get 10 root 2 over 2, which is by root 2, and that is both your x and y. So you could have done it with the Pythagorean theorem, but please get comfortable with the 45, 45, 90 method because you are going to need that with some other trig stuff that we do. Like you need to be familiar with those numbers.
I did like square root of
I kind of just did it. What do you mean?
I figured out it has to be square root of 50.
How'd you figure out it has to be the square root of 50 though?
The h square root of 2.
Okay.
Because it has to be 10.
Because you need it to be square root of 100. That's the same thing, just not algebraically. All right, number 3. What did I give you this time?
The long.
Long leg. Yeah, remember that is equal to root 3 times the short leg. So for us, 8 is equal to root 3 times x. So I divide by root 3. I need to rationalize. I get 8 root 3 over 3 for x. That's the short leg. How do I find the hypotenuse? Okay, what do I get when I multiply that by 2? Over? Okay, good. And that is the end. Okay? Special right triangles should be something that you know, okay? They will keep coming up, so make sure you practice them. All right, any questions before we start the notes? Okay. Guys, we have a lot of definitions that we have to do today. We're going to talk a lot about angles. So first we have the initial side of our angle. It is where the angle begins. And for everything we're going to be doing, that's going to be on the positive x-axis. So I'm going to draw a little angle over here. Okay, there's my angle. So the initial side is this side right here on the positive x-axis. Up next, I have the terminal side. What do you think the terminal side is? Where the angle ends. So this side over here is the terminal side. So guys, which quadrant is that terminal side in? 2, okay. You remember numbering your quadrants. Down here would be 3, 4, first quadrant. All right, up next we have just standard position. And this is talking about where the angle is, and all of your angles will be like this. Vertex is at the origin. And as we talked about before, the initial side is on the positive x-axis. So look at my terminal side for the one I drew. Is it on the negative x-axis?
Oh.
It can be anywhere. Like, it depends on what size your angle is. But the initial side always starts on the same spot. All right, we can have a positive angle. This happens when your angle will travel counterclockwise. So let's look at the angle I drew. If I want to name that as a positive angle, I start on the initial side and travel counterclockwise. Like, that's the direction I'm going. I'm going to say this is about 120 degrees. I'm obviously just estimating, but we'll call that positive 120. Now, we can also have a negative angle. What do you think is going to happen with that? Yeah, when you travel clockwise. So I can show that on the same angle that I drew. Instead of traveling counterclockwise, if I travel clockwise, this has now become a negative angle. How big do you think that negative angle is? Yes, negative 240. There are 360 degrees in a circle, so these two angles combined create that 360 degrees. So it looks like the exact same angle, but how you label it tells you whether it's a positive or a negative angle. And this leads us to coterminal angles. These are angles that have the same terminal and initial sides. But different measures. Yeah, Bauer.
look at the negative numbers, would it be incorrect for me to think of it as everything above is a positive angle and everything below the angle would be a negative angle?
So, what about that angle? Because going this way is positive, even though the angle ends up below the x-axis.
Yeah, so how are we thinking that way? Is that incorrect?
Well, do you, by your way of thinking of that, do you see that as a 200-degree angle? Okay, then no. Because you can have, it's all about the direction. If you go like multiple times around, you can have an angle here that's more than 360 degrees, depending on where the terminal side is.
Wait, you can do that?
Yeah. Probably shouldn't have just drawn a spiral and made your heads explode, huh? Exactly. Yeah. We'll talk more about that. All right, so coterminal angles. So the one I drew up above, positive 120 and negative 240. Those are coterminal angles. They have the exact same initial and terminal side, but they're named in two different ways. Okay, 120 degrees, negative 240 degrees. If you draw them, they end up in the exact same spot, but they have different names. So the way you find a coterminal angle is by adding or subtracting 360 degrees. Because you're going all the way around the circle from your terminal side of the angle. So let's try one and see if you guys understand what I'm saying. Find two coterminal angles to 100 degrees. So like 100 degrees is the angle I'm giving you. I need you to find me two coterminal angles. There's actually an infinite number of coterminal angles. All of your heads popped up. It's really funny. No. Those are not exactly the same. Yes.
Is there any abbreviation for coterminals?
No.
Is one negative? Oh, wait.
Keep thinking, guys. Don't make this harder than it is. That's what I'm saying. Don't overthink this.
I got it.
Just took a minute. We're there now.
I thought it only goes in 360.
You can go over 360. That's what that spiral was.
Negative 260.
I think you have 46 and 51.
All right, guys, there's two of the answers. Well, almost. 460 degrees and negative 260 degrees are two potential answers. Now, if I don't specify a positive and a negative, you could have said, okay, 460, and I just really like adding, so I'm going to add again and say 820. There's usually someone who likes to be a pain and add 360 like 10 times and tell me what that answer is. And yes, that is still a coterminal angle, but Usually it's a positive and a negative that I'll ask for, okay? Does it make sense, guys? Like, do you see it? If you were to draw them, like let's say I said draw for me, you don't have to write this down. What do I want to give you? Draw 60 degrees for me. Where would that be? Like, which quadrant would I be in? Okay. 1. And then what if I said draw negative 300 degrees? Where would that be? Right, okay. That's coterminal angles. They look exactly the same when you draw them, but they have different names, essentially. Does that help a little? No, they're just literally 360 degrees apart on the circle. Okay? All right, shall we continue? All right, next definition is for reference angle. The measure between the terminal side and the closest x-axis. Must be positive and acute. Okay, so let's try one. Find the reference angle. For 210 degrees. Okay, when you're finding a reference angle, you either want to just make a little sketch of the angle that's given to you or visualize it in your head. Where is 210 degrees? Like, where's the terminal side of that angle? Quadrant, okay, I'm hearing 2 and 3. Let's think about it. Over here where we start is 0 degrees, right?
It's 180 lines, so it's below.
I am asking, where is 210 degrees?
Oh yeah, yes.
All right, perfect. So here's the angle I'm talking about, right? There's my initial side somewhere in here. It's my terminal side. That's 210 degrees. What I'm talking about for a reference angle is this distance between the terminal side and the closest x-axis. That's this part over here on the left in this case. It's the closest x-axis, like part of it, to the terminal side. So if you try to use the other one, this distance, isn't that going to be not an acute amount of distance? Like, isn't that going to be more than 90 degrees away from the other x-axis? If it ends in quadrant 3, you're always going to be going to the 180 degree side of the x-axis. Yes. The reference angle is always positive and acute. Guys, hold on. I can't hear the question. Go ahead, Colin. What do you mean from the reference? Oh, so like a 30-degree reference angle. That could be 210 degrees. It could be 330 degrees. It could be 150 degrees. So yes. Okay. I understand what you're saying. So guys, that's essentially distance, angular distance that we're talking about there would be 30 degrees. Are you with me? Let's try another one. We'll call that one part A. So let's find another reference angle for 310 degrees. And again, draw the picture if you need to, or visualize it. You are never, ever, ever, ever going to the y-axis, okay? Always, everything is to the x-axis. Never, never, never the y-axis. So you're figuring out how far from 180 or how far from 360? I won't ask you that because technically it'd be 90 degrees, which is not acute. So, yes, that is correct. We use this when we get into the unit circle. Guys, you use this to help yourselves in the unit circle when you're into like weird quadrants and you can reference a first quadrant angle. So we're not going to worry about the 90 and 180 and 270. Okay. All right, guys, what'd you get for this one for 310 degrees? 50. Yes. Anybody questions on reference angles? Okay. No worries. It's going to be good times. Yeah, that's a circle. Not yet. We will get to the unit circle. Next week, I think. All right, we are going to define a radian. So guys, degrees, that's one way to measure an angle. You can also measure angles in terms of radians. Okay. All right, let me write the whole thing, and then I promise I will explain it with a picture afterwards, but let's get it written down first. So a radian is the measure of a central angle whose intercepted arc is equal in length to the radius. Again, write it down. I will explain. Yes, intercepted. P doesn't really look like a P. So guys, let's make sure we know what all of these words mean as step one. You know all these words? Okay, good.
So, like individually.
Central. Yes, I know that word. Angle. I know that word. All right, guys. What is a central angle? The vertex is on the origin. Okay. Everything we will look at is a central angle. Okay. I won't change the rules on you. All right. What is an intercepted arc? Okay. Like, so let's say here's my angle. Do you see the arc that it intercepts? That's the intercepted arc. That. It's like the arc of the circle that it cuts out. Like it's your piece of pie. Okay? It's the crust of your pie. Okay. All right, and then we're saying if this is a radian, the length of that intercepted arc. Now it's curved, so if you could straighten it out and measure it, would be the same as the radius. That's how it works if it is 1 radian. So if this arc length is the same as the length of the radius, I think I need to make mine slightly bigger. You can do this with like a piece of string and measure it out and mark it, but we're not going to have string time today. Sorry, guys. No string time today. All right, so that angle in there is 1 radian. Okay. Oh, thank you. All right, let me show you something interesting. Okay, so we'll wait for the screen to come back and then I'll show you something interesting. So right there on the circle, that was 1 radian. Okay, I'm going to mark off that same distance around my circle. I'm approximating, obviously. We'll call that 2 radians. 3 radians. By the time I get over here to 180 degrees, it's 3 and a little bit of radians. Do you know a number that is 3 and a little bit? Yes. Oohing an eye. So that is where this conversion factor comes in by turning things into radians, having pi involved in them. If I keep going, 4, 5, 6 and a bit, 360 degrees is the same as 2 pi. 2 pi radians is a full circle. Yep.
1 pi.
It's interesting, right? What? I'm sorry. 360 degrees.
Did you ever watch the Rumble?
Yeah, because you draw it on top of it. So. Yes, exactly. So when we get to creating the whole unit circle, it all the radians come from this idea that pi and 180 are the same thing. Okay? We're not doing the unit circle today. Soon and very soon. We are going to convert today, though. Converting. Yes. Converting. We're converting from degrees to radians and from radians to degrees. Like inches to feet, right? You know how to convert. You aren't excited about converting?
That also means like factorials.
I love that.
Factorial is exciting.
We have to do that.
All right, let's try one here. Okay, 30 degrees. So our conversion factor comes from what we just labeled on the circle up above. You guys know, like with distances, 12 inches is 1 foot, right? Like that's a special way to write 1. 12 inches over 1 foot is actually 1. So with degrees and radians, 180 degrees is the same as what radian? Pi. So if I write 180 over pi or pi over 180, that's just a fancy way of saying 1. Okay, like they mean the same thing. They're at the same spot on the circle. The angle is the same size. So we use that to convert. So if I'm going from degrees to radians, I want to end up with radians. So the radians is in the numerator. The degrees is in the denominator. And I just multiply. Reduce. What is 30 over 180? That's like 3 over 18. 1/6. So this is pi over 6.
That's awesome.
Have you try another one? Does that make sense what we're doing there, guys?
Yeah.
Okay. So what if I start with 240 degrees? You guys try that one.
So 180. Oh, you did it 180.
Did we get 4 pi over 3? Sorry guys, my voice is not great today.
So it's a little bit more than 4 radians.
It's a little bit more than 1 radian. It's 1 1/3 radian, right? Maybe. Okay. All right, guys, let's go the other direction. So if I'm starting with radians and want to end up with degrees, yes, Henry?
From degrees to radians, the denominator.
Yeah, the degrees cancel out there. Yep. It's like inches. It's your unit of measure. Yeah, this time I'm going to multiply by 180 over pi. I want to end up with degrees, so that's in the numerator. Okay, please reduce before you multiply. So the pi's are going to cancel. Okay, we'll see after one. Reduce 180 and 3. What am I left with? 60. And what is 2 times 60? This is 120 degrees. Okay, let's try one more.
Yeah, 60 times 2. Because it was
Pi, 2 lines, squiggle.
No, if it was, you could do for 60.
Yeah, if you don't like the squiggle, you can do 2 lines. That's fine, totally acceptable.
Without the squiggle.
Again, guys, reduce before you multiply. I don't want to do 7 times 180. That does not sound very fun. So you're thinking about what you want to end up with. If I want to end up in degrees, degrees needs to be my numerator. So think like if I have 20 inches and I want to know how many feet that is, I would take that times 1 over 12, 1 foot over 12 inches. Yeah? Okay. Tying it back to something you already know always helps. Yeah. And guys, this would be all without a calculator, just so we're clear on that. 180 over 50? Well, you could reduce that. Reduce as much as you can. Like, I mean, it could be a weird one that doesn't reduce, but, like, reduce as much as you can. All right, guys, what did we get? Yes. Okay? All right. Guys, that is the end of the notes. We're going to do some practice problems now. You can do them in your notebook. You can do them on a whiteboard. It's only 3 problems, but they took a little while in second period. So wherever you want to do the practice.
It's like only one of us know.
I have another exclamation point for you guys. Practice. Yeah, do these either in your notebook or on a whiteboard. I don't care, but I just want you to practice these problems. You can work together. The first one is nothing that we went over today, just a throwback geometry question. What do you know? Which I don't know that you know much from geometry, so we'll see.
Oh, sides.
So in an isosceles triangle, they are the 2 congruent sides. So like in the one I've drawn, I'd probably say these 2 are the legs. And then find H. Again, nothing that we learned today. You just need to try to find H. No. No.
The height, it's like 2. No, it's like 2. It's like the base times 2. What about height? The whole point is to find H.
We'll give you credit.
Wait, you're supposed to.
Gold star for so.
It's 24.
No.
Wait, that's the area.
Yeah. No.
Oh, wait, it's the 30, 60, 90. Which means that you go.
No. No. Yes.
Oh, right.
Pythagorean theorem, guys.
Oh, yes. I know that.
This is it already.
I do know that.
Wait, I'm reading with 3. No, it's 3.
Okay, minus 3. You are fucking.
Wait, 55. Yeah. Yes? I don't know what that's.
What's root 55? Root 55 is 6. Never mind. Go
Are we ready, guys? Think about this side would turn into 3 when we cut it in half. Good job. All right, guys, questions on that one? Took you a minute, but once you remembered the Pythagorean theorem, we were okay? Yeah. Okay. No, we're not okay. Yeah, we're fine. Some of you are okay. All right, this you did learn today.
She said, like, honestly, geometry is from my I do remember this. Alright. You can multiply by 5. 315.
Just keep guessing.
Yeah, wait, yes, 36. 36 times 5 is 180. So 63, that's a prime number. No, 5 by 3. No, by 36 by 3. 11.
No, you can divide them both by
21. Oh, you can't.
so then you get 4.
No. No.
7 over 4.
Keep going.
Keep going.
Yay!
It's 7 over 4.
No, behind you.
It's 7 over 4.
Okay.
I can write my own answer.
You're taking too long.
Yes. No. I think you just need to reduce more, Lana. Yes.
That's a lot of reduce.
No.
Easier, but
Yes. Henry, let me see.
Oh.
Yes. You're good.
Yes.
Not quite. I think you just reduced wrong. Yes. Okay, guys, we'll go over it after lunch.
every time.
Were we done with our 315 degrees? Yes. Okay. What'd you guys get? Yes. And guys, if you're struggling with the reducing, just pick some, like, okay, I can divide it by 3. Like, start small if you need to, and just reduce multiple times. Like, that's fine. You don't have to have the biggest thing to reduce, okay? Yeah.
5 by 1.
You're not reducing.
Okay.
I do.
Did you try to reduce with anything? That's a multiply in there. 5 first. You could even do 3 first if you wanted to. If you did 5, what is 315 divided by 5? Because this is what I'm really thinking about. 63. And then what about 180 divided by 5? 36. From there, you could divide by 3, or you could divide by 9. And you get 7 over 4, and then that's the end. No, does that make sense? Okay. All right, guys. One more on our practice. You do need to use some of what you did in the warm-up today with this. This is definitely the trickiest of the 3 questions, so I'll give you a little bit of time to work on it. This one's going to take you a minute to do. You end up with a radical in a radical is one way you can write it. There's a lot of ways you can write this answer. So
One half base up. Oh!
So base times height has to equal 10. Yeah. I see. How does one does? Obviously. B equals 10.
Wait, so the base one? 45.
Yes.
Yes, 60.
Finding half of it. That was probably maybe a 60, 90. Oh. Wait, that's so happy.
Oh, wait, we have no space for you guys.
Mm-hmm.
Next Wednesday, I'm gonna English. So we're going to Mount Vernon for
Or something related to Mount Vernon. Okay. Yeah, but so Wednesday is like, what day is it? So, okay. We'll do.
The base.
So we'll start on properties and trig. But there'll be a video. Okay. Okay. Yep.
And then you get the base. Oh. You did.
You cannot write it down. Probably need to do
This guy is.
Yeah. Yep. I need it in radical form.
It's like radical in a radical.
Mm-hmm.
So like that.
Not quite. You're on the right track, but not quite.
Okay. I'll take that.
What? I want to step one.
No.
Oh, what are we supposed to do? How do you get
Right?
No.
That's right.
Yes, that is right. Not quite. Sorry, I'm thinking of all the different ways you can write it. You're on the right track.
Oh my god.
Close, but not quite.
I agree.
Jonah.
Kinda. But that's not But it's a way to solve it, or kind of? You're definitely doing it a little differently. But you do need the root 3 and all of that, but you're missing something. No.
Is it not 4-4? Wait, that would be.
If you're doing this equal to 2.5, then this would have to be x over 2. And this, like, if you do it this, just set it equal to 5. You're still a little off, but you're on the right track. Not quite, no. Closer. Oh, this one.
Triangle height 5. So what I did is I just put 5.
I don't see what you're doing. Okay.
I want to do the ratio of okay, so I feel like I'm going wrong somewhere because I'm square root square root.
No, you should have a square root.
So is this right?
Yeah.
How do you square root square root?
I mean, if it was just like a double root, that's
How do you square root and square root wrong?
This is the one that comes on.
Where are they getting
Because I don't think I'm supposed to factor.
no.
Okay, I didn't think so.
I know what you gotta do.
Hey guys, let me give you a little help here. It's an equilateral triangle, but I don't know what the sides are, so I'm going to call them all x. When I draw in the height here, that's become x over 2. What kind of triangle did I just create? Okay, x over 2 is the short leg, so what's the long leg? Not just x root 3.
X over 2.
So the short leg is x over 2, right? So I take that times root 3. Yeah, so it's x root 3 over 2. That is the height of your triangle, guys, when you're using your area formula. So 5 equals 1/2 x times x root 3 all over 2. Go from there, guys.
What?
Wait, if you're squaring two things, oh wait, it's a cat.
You want to find it.
I just did an x over 2 instead of x root 3.
Oh, you put your 2 there instead. Well, what's 2 times 2? Oh.
1.
What's 2 times 2?
Oh, 4.
So that should be over 4.
Oh.
You see it? Okay. You're getting there.
So I think
Is this right?
okay.
Wow.
I don't know what
That's squared.
This is the latest thing.
No, I thought you already had it.
Yeah, that's just that simple.
Oh, I don't have time.
I didn't want to. I basically got that one.
Yes. Yes. Maybe.
That's
You're right.
2 times x. Everything. Yeah, I was there.
Five and one half minutes. And then you publish
What? Oh, you're actually. I got it. Just like.
hard on that, bro.
Oh my god.
It's fun to play with, bro.
Square root of 5, 4 root of 3 divided by square root of 3. You get square root of what?
Like different numbers up here, but let's say you had.
Jonah, what did you get? I swear you are. Is it square root of 6?
I just love this.
That's really.
I just simplified it.
Yes, see, this is why you do it.
Okay, that's what I meant.
I know.
That's what I meant. Oh, okay.
See what I mean?
Okay, yeah. But I mean, you could combine it.
But then you wouldn't be multiplying by just a square root.
No, because it's 3 to the 1.
Right, but you can multiply. If you're going to combine it with the root, you have to multiply with something.
Squared.
You'd have to multiply.
What about like exactly backwards and x to the 1/2? Couldn't that be x to the 1/2?
Oh, it's not right.
Okay, but think about like square root of 2 times. That's a cube.
Oh, never mind, they're multi-step.
And that's what you're trying to do. So,
Yes. Here to that.
match, like,
Okay, I have to stop.
guys, you need to rationalize this because you guys are losing your minds with your rationalizing. Here, let me go through it up here. Just
Yeah.
Jonah, you could stop. So I didn't have to rationalize.
know it's okay.
Wait, so this is fun?
All right, so we should have 5 equals x squared root 3 over 4, okay? I just multiplied straight across.
Yeah, no,
X times x, 2 times 2.
I know, I got it. The area is 5.
Then I'm going to multiply both sides by 4.
Oh, she hasn't. Yeah.
Yeah, I'm just
Yeah, that's what I got.
That's what I got.
Look at that.
I would take that. Some other answers that are the same as this, you could technically have 2 root 5 over the 4th root of 3. Some of you tried to rationalize. If you rationalized from here,
I got close.
and then the square root of that, that is an acceptable answer. That is an acceptable answer. Some of you kind of went a little bonkers simplifying from here. You tried to rationalize. It would be root 60 square root of 3 over 3. And then you can simplify that. Yep. So what is that? 4 times 15. 2 root 15 root 3 over 3. So that's another way you could write it. This one is probably the easiest one, guys. Some of your rationalizing got a little weird. When you're rationalizing with a radical under a radical, it's interesting. Charlotte, you could have, like if I go from this one over here and rationalize that, it'd be 2 root 5, 4th root of 27. You could get to that. But it's pretty ugly.
Yeah.
Some of these others are a little prettier, I'd say. All right, guys. That's the end of your notes and practice. You do have math-based homework waiting for you. Now, it's been a little while since we've done math-based. So, when is it due? The end of tomorrow. Yes, the next school day at 11:59 p.m. Second period, everyone was like, it's due the next class. I was like, no, not at all. So, please get started on that. Let me know if you have questions.